Hi everyone, today we're going to work on 3.1 homework, which is about functions. I'm going to work on some of the questions for you. I will start with question number 7, which is giving us this function and it's asking you to find f of 0, f of 1, or f of 5x, and so on for this function. So I'm going to start with f of 1. So all I need to do is plug in x as 1 here and evaluate the function when x is equal to 1. So f of 1 will be 3 times, instead of x, I replace 1 plus 8 over 2 times, again, x is 1 minus 5. And now the top will be 3 times 1, 3 plus 8 is 11. 2 times 1 is 2, minus 5 is negative 3. So this is the value of the function for f of 1. Let's see what is negative f of x. So negative f of x will be just whatever is your f of x, which is this expression, just put a negative behind as 3x plus 8 over 2x minus 5. You can distribute the negative, and this is going to be equal to negative 3x minus 2, minus 8 divided by 2x minus 5. So this negative will be distributed only to the top, not to the bottom. What is f of negative x? F of negative x means wherever you have x, you just plug in negative x instead of that. So I will have 3 times negative x plus 8 over 2 times negative x minus 5. So I will have negative 3x plus 8 over negative 2x minus 5. So that is f of negative x. Now let's see what is f of x plus 3. Okay, to find f of x plus 3, wherever I have x, I plug in x plus 3 instead of that. So I will have 3 times, instead of having x, I'm going to write x plus 3 here. And then in the bottom, 2 times the x will be x plus 3. Now I can simplify by distributing the 3 to this parenthesis and this one over here. So I will have 3x plus 9 plus 8 on the top, and then 2x plus 6 minus 5 in the bottom. And I can simplify 3x plus 17 over 2x plus 1. So this is f of x plus 3. Now let's see what is f of x plus 8 here. To find f of x plus 8, I'm going to plug in x plus h instead of x here. So here this will be x plus h times 3 plus 8 and 2x plus h minus 5. Now it's time to distribute and simplify. So 3 times x, 3 times h will be 3x plus 3h plus, I already had an 8 here, and in the bottom, 2 times x, 2 times h minus 5. And I cannot simplify this anymore because there are no like terms here. So this will be the final answer. On question 8, we need to find the domain of this function. We see that we have a fraction here. We know that if we have a fraction, the denominator can never be equal to 0. That is going to help us find the domain of the function. So we don't want the denominator to be equal to 0. So I'm going to look for any values that could make the denominator 0 and then exclude that from my domain. So is there anything that makes x squared plus 7 equal to 0? Let's find this. So I'm going to solve for x, subtract 7 from both sides, and x squared equal to negative 7. In order to solve for x, I have to take a square root of both sides. So this is going to cancel, and x is the square root of -7. But I know that there is no negative on the radical. There should be no negative on the radical. So this is not acceptable. So there is nothing that makes the denominator equal to 0. So that means the domain is all real numbers. So if I want to write it in interval notation, I'm going to write -infinity to +infinity. And sometimes we don't even need to write the positive here. So we can just write -infinity to infinity. On question number 9, we want to find the domain of this function. Again, the same way, I'm going to look for any value that makes the denominator equal to 0, because if the denominator of a fraction is 0, the function is undefined. So I'm going to look for values that make denominator 0. So I put x squared minus 4 equal to 0 and solve for x. So add 4 to both sides and x squared equal to 4. And then I take the square root of both sides. This time, because on the radical we have a positive number, we can easily take the square root. So x is equal to +2, that's the square root of 4, and -2. So we have two values that make the denominator 0. I'm going to exclude these from my domain. That means the domain is all real numbers except these two. So how do I write that in interval notation? I'm going to draw a number line for you. This is 0. Let's say here is 2 and here is -2. So my domain is everything from -infinity except -2. And then after that, everything is defined except 2. And after that, everything is defined. So how do I write this as an interval notation? We start from -infinity. So parentheses, -infinity. When we reach at -2, we have to stop. There is a gap here. So I'm going to put open circle, which is parentheses. After this point, I'm going to start with after -2 and continue moving, and there's nothing on my way until I reach to 2. So I'm going to write 2 here. Again, 2 is not defined, so open circle, that means parentheses, and then after that again, parentheses, 2 to infinity. After 2, we can continue. So between these points that we have a gap, we're going to write this symbol, which is U. That means union of the sets. So this is my domain here. To find the domain of this radical function, we need to know that on the radical with index 2, which is basically called the square root, we cannot have a negative number. So whatever we have on the radical should be positive. So this is going to help me to find the domain of the function. Whatever I have on the radical should be greater than or equal to 0. Now solve this for x. Just act like you have a normal equation. What do you do here to get the x by itself? We're going to add 15 to both sides. So I will have 5x greater than or equal to 15, and then divide by 5. So x will be greater than or equal to 3. Now, how do I write that as interval notation? On the number line, if I show this number, this is 0, this is 3. So domain is this number and everything after that. So I can write 3, and I put bracket behind that because there's a closed circle, because I have an equation greater than or equal here to infinity, and parenthesis here because it's going to continue forever to the right side. Question 12 is asking us to find f plus g of x. We have two functions, f of x and g of x, and we want to add them together. So all we need to do is write the equation for each of them, 7 plus 6 over x, and then 6 over x, and we're going to add them together. Okay, so 7 is going to be here. 6 over x plus 6 over x will be 12 over x, because if you have two fractions with the same denominator, you can keep the denominator and add the tops together. So this is basically your f plus g uh, of x. Okay, so f plus g of x. We also need to find the domain of the result function. So we know that in order to find the domain of a function, which is sum of two other functions, we basically need to domain of each function and then find the intersection of those two. So let's see. Domain of f is basically all real numbers except whatever makes the denominator here equal to 0, and that is 0. So if x is equal to 0, this denominator is 0 and makes the function undefined. So the domain here is all x values such that x is not equal to 0. This is for f. Now I'm going to find domain of g. What is domain of g? That is also the same, because the only value that makes the denominator is denominator equal to 0 is x equal to 0. So all x values such that x is not equal to 0. Now, domain of f plus g is basically domain of f, and this symbol means intersection of these two. That means whatever is in common between them. The domain of g. What is that? Since they are both the same, so the domain of f plus g will be again all x values such that x is not equal to 0. Next part of this question is asking us to find f minus g of x. So to find that, you're just going to write 7 plus 6 over x, and then the other one is 6 over x. This time we're subtracting g from f. And what is the result? Well, 6 over x and 6 over x, they will cancel each other, and the answer is 7. So that's the function f minus g of x. Now, what is the domain? Again, domain of f minus g is domain of f intersection with domain of g. So what is domain of f? Domain of f, we said it's all x values that x is not equal to 0. Domain of g is also the same, x not equal to 0. So intersection of them will also be the same. All x values that x is not equal to 0. Next, we want to find f of g times g of f of x times g of x. So you're just going to multiply these two functions to each other. 7 plus 6 over x times 6 over x. Okay, so in order to multiply those two, I'm going to distribute 6 over x into these two terms. So it will be 42 over x. When you multiply 7 times 6 over x will be 42 over x. And then plus 6 over x times 6 over x will be 36 over x squared, because you multiply top by top and the bottom by bottom. Now I can simplify. In order to add these two fractions, I need to have the same denominator. So I multiply this one by x and the top as well by x. It will be 42x over x squared plus 36 over x squared. And the result will be just 42x plus 36 over x squared. Domain of f times g, again, will be domain of f intersection with domain of g, which, again, we know each of them is x not equal to 0. For both of them, it's the same. So the domain of f times g will be all the x values such that x is not equal to 0. Okay, next we want to find f divided by g of x. So I'm going to start with writing f here on top of the fraction 7 plus 6 over x divided by g of x, which is here. We know that if we want to divide two fractions, we do keep, change, flip. So I'm going to keep the top, which is 7 plus 6 over x, and then change the division to multiple and flip the second fraction. That's going to be x over 6. Now it's time to distribute them. Okay, so this will be 7 times x over 6 plus 6 times x over x times 6. So multiply top by top, bottom by bottom. And as you see, these two cancel each other. These two also will cancel each other, 6 and 6. So what is left here is 1. It's not nothing, it's 1. And the first term will be 7x over 6 plus 1. To find the domain of f over g, we need to find domain of f intersection with domain of g, but also we need to make sure there is nothing that makes the denominator of this fraction 0. That's g of x. So we want to look for all the x values such that g of x is not equal to 0. So what is that? G of f, domain of f is all x not equal to 0. Domain of g is all x which is not equal to 0. And the same is here as well. I need to know what is the value that makes the g of x equal to 0 and then exclude that. So what is g of x is this? 6 over x. Is there any value that makes this 0? There's nothing because the top of the function is 6. The bottom, there is no x value that makes this equal to 0. So there's no number for this one. So the domain, the intersection of all these sections will be just x such that x is not equal to 0. For question number 13, we are trying to find f of x plus h minus f of x over h. So all I need to do is plug in these values as x into the original function and simplify. So I'm going to start with f of x plus h, which is negative 6. Instead of x, I put x plus h plus 9. So this is f of x plus h, the first one. Next, I need to find f of x, which is already whatever I have here. So I can write negative 6x plus 9 here. Next, in the bottom, I'm just going to write h. Now we start simplifying. So negative 6 distributes here. I will have negative 6x minus 6h. And I have a plus 9 here. And then this negative will be distributed here. I will have negative times negative plus 6h. Negative times 9 will be negative 9. And the denominator is h. Now let's simplify. Negative 6x and plus 6x cancel. 9 and negative 9 cancel. And I will have a 6h, negative 6h on top and an h in the bottom. So the h on top and the bottom cancels. The answer is equal to negative. Question number 14, let's find the same thing for this function now. Okay, I'm going to start with f of x plus h here. So instead of x, I will put x plus h squared minus 9 times x plus h plus 5. This is the first one. Minus The second one is f of x. So x squared minus 9x plus 5. And the denominator is h. Now let's see what is each of these now. X plus h squared, we know that it's just, I'm going to write that here, x plus h squared is x plus h times x plus h. So when you distribute and simplify, you're going to end up having x squared and an h squared here, and here plus 2xh. This is the first one. And then distribute the negative 9. You will have negative 9x and negative 9h plus 5. Now distribute the negative. So we'll have negative x squared plus 9x minus 5. Now let's see if there's anything that we can cancel out. This x squared and this one will cancel. There's a negative 9x and positive 9x here. 5 and negative 5 cancel. And what do we have left here? We have 2xh plus h squared plus 5h over h. Now, is there anything that can be canceled out here? Yes, I can factor the h from the top. So there is an h on top that I'm factoring out. So I will have 2x plus h plus 5. And in the denominator, I had an h. This one on top and the bottom, they will cancel each other. And the result will be 2x plus h plus 5. Question 16 is asking us if this is my f of x and f of 2 equal to 9, what is the value of a here? So I'm going to replace x with 2 here first. So f of 2 will be 3 times 2 to the power of 3, that's this one, plus, this is 2 squared, which is 4 times a. So I'm going to write a times 2 squared plus 3 times 2. Wherever you have x, replace it with minus 3. And this is equal to 9. So now I just have a linear equation, and I'm going to solve for a. So this is 8 times 3, 24, plus 4a plus, this is 6 minus 3 equal to 9. And then you're going to solve this for a value. I'm going to leave that for you to solve. Question 18. An airplane crosses the Atlantic Ocean with an airspeed of 600 miles per hour. The cost in dollar per passenger is given by this formula. Now, and also we know that the x is the ground speed. That means airspeed plus and minus wind. Now it's asking what is the cost per passenger for quiescent, which means there is no wind condition. So if there's no wind here, that means whatever is the speed of the airplane is going to be the same. Nothing will be added or subtracted from that. The wind is 0 here, so the speed will be just 600. Now all you need to do is replace the x with 600 and find the cost. So it's just going to be 150 plus 600 over 20 plus 30,000 over 600. And then you can use your calculator to find it. I'll leave this for you. Question number 19. Suppose that the revenue R in dollar from selling X cell phones in hundreds is Rx equal to this function. And the cost in dollar from selling X cell phones in hundreds is this function. Now, part A is asking us to find the profit function, which is just Rx minus Cx. So all you need to do is subtract these two functions from each other. So negative 1.3x squared plus 202x. You're going to subtract C from that, which is this function 0.01 x to the 3 minus 2x squared plus 30x plus 60. So you need to, sorry, plus 600. You need to subtract this from this. All I need to do is distribute the negative here and then combine the like terms. So I will have negative 1.3x squared. That's the first part, which is going to remain the same. And now negative 0.01 x to the 3. Negative times this negative makes it positive 2x squared. Negative times positive makes this one negative 30x. Negative times positive makes it negative. Now it's time to combine the like terms. So x to the 3 does not have any like terms. I'm going to start with the one which has the highest power, 0.01 x to the 3. And now x squared and x squared, they can be combined. So negative 1.3 plus 2 will make it 0.7 x squared. And then this one, 202x and 30x. This is negative, this one is positive. So you need to subtract them, which will be positive 172x. And then I have a negative 600, which is alone here. So I'll keep it. So this is our profit function. Part B is asking us, find the profit if x is equal to 2,300 cell phones. And all you need to do here is plug in x as 23. So 0.01 times 23 to the power of 3 plus 0.7 times 23 to the power of 2 plus 172 times 23 minus 600. I will leave this for you to find the answer. Next part is asking us to find the interpretation of P of 23. That means just if 2,300 cell phones are sold, then what is the profit? So it's just giving us a profit when we sell 2,300 cell phones. Question number 22 is asking us to use the interactive figure to find the answer of f of negative 2.7 if the function is greatest integer function. So this is the interactive figure here. So you're going to choose greatest integer function from this option over here, and then make sure you choose show values, then move this button to the left side until you see the value of negative 2.7 for x. So once you have that, the value of the function is given here and also here. So it's equal to negative 3. Question 23, we're using this function and using interactive figure to find the smallest value of the function. So all you need to do, once you have your function chosen here, x squared minus 5, just look at the function. The smallest value is the lowest point of the function, which is here at negative 5. You're going to choose the y value. X is 0, but it's asking for what is the smallest value of f of x. So it's going to be negative 5. You write the y value of that. For question 26, again, we're using the interactive figure, and we're going to check secant line, the slope of secant, and values boxes, and then set the x slider to x equal to 4.5 and x plus h to 6.5. And then we're going to answer these questions together. Okay, so for this part, I chose secant line, the slope of secant, and values, and move the x to 4.5, the x plus h to 6.5. Now, the answers that I can choose are these. The top will be this number minus this number, and the bottom, which is h, is this minus. So this is h, and whatever is the answer to the top is f of x plus h minus f of x, and the result is m. So you're going to write this for m, this for h, and this one for the first option. So the answer is 14 on top here, 2 and 7. You're going to use the same method to work on the other questions which have interactive figures to solve the questions. I hope this was helpful for you. Have a great day.